Hello everyone. Today we are going to discuss about 8253, 8254, which means programmable timer or counter. The content of these is 8253, pin diagram of 8253, then architecture of 8253 and modes of 8253. 8253 is operating in different modes, and then last is references from where I took these content. Now, first of all, what is 8253? 8253 is a programmable counter. Programmable means we can program this device, and it includes three identical 16-bit counters. Three identical means there are three counters. Each counter is of 16-bit. It is packaged in a 24-pin DIP. DIP means dual inline package. 24-pin means the IC is of 24-pin. In DIP, we have an IC, and in that IC, we have pins on two sides like this, left and right side. This is a DIP architecture. Here, six programmable modes. Six programmable modes means mode 0 to mode 5. In this modes, 8253 is working. Now, features of 8253. The most prominent feature of 8253 is it has 16-bit down counters. Down counter means we need to start the counter from X value and it will decrease this value automatically. It can handle from DC to 10 MHz frequency. Means the 8253 can work up to 10 MHz frequency. The three counters in 8253 can be programmed for either binary or BCD. Means we can take two types of counter here, like either binary number or BCD number. We can use any of the number format. It is compatible with almost all microprocessors. Means 8085, 8086, 8087, 8088. What kind of microprocessor it is, it will be compatible with the all available types of processors. 8254 has a powerful command called read back. The difference between 8253 and 54 is, like in 8254 there is a command known as read back, which allows the user to check the programmable mode and current status. Means by using this read back command, the user can check the different status and modes of the counter. Intel 8253 and 8254 are programmable interval timers, okay, designed for microprocessors to perform timing and counting functions using three 16-bit registers. Each counter has two inputs. Means अब हम count now. It means we are monitoring about the counter. Okay, so counter has two inputs and one output. The input is clock signal and gate signal. The input signals are clock and gate, whereas output signal is named as out. Two input pins for clock and gate respectively, and one pin for out signal. To operate a counter, 16-bit count is loaded into the register. Now, what we have to do, we have to load the 16-bit value. The 16-bit value is loaded into the register and it will automatically decreasing. Like if we load a 16-bit number like F, F, F and F. This is a 16-bit number and it will reaches to 0. Until it reaches to 0, the counter will automatically count the cycles and decrease this number. Difference between 8253 and 8254 is 53 is working on up to 2.6 MHz, whereas 8254 can work up to 10 MHz. It is based on NMOS technology and 8254 is working on HMOS technology. Read back command is not available in 8253, but Read back command is available in 8254. Read and write of the same counter cannot be interleaved in 8253, but it is interleaved in the case of 8254. Next is architecture of 8253. Now, in this architecture, we have two parts, left part and right part. The left and right parts are basically, in the left part, we have data bus buffer, control logic, control word register. In the right portion, we have three different counters, each of 16 bit. All the counters are of 16 bit each. And it is named as counter 0, counter 1 and counter 2. Each counter has three signals: clock 0, gate 0, out 0. It is for counter 0. The signal is clock, gate and out. It is similar for each and every counter. Clock, gate and out is similar for every counter. The 0, 1, 2 based on the counter. Counter 0, then clock 0, gate 0, out 0. Counter 1, clock 1, gate 1, out 1. Counter 2, clock 2, gate 2, out 2. Now, data bus buffer means it is having a 8-bit data bus. Read write control logic means read signal, write signal. Both the signals are active low. Then A0, A1 address pins, and CS is again active low signal, which is known as chip select. It is to enable the 8253 or the circuit. Then control word register, it is used to provide the control word, means how to do, what to do. This is the pin diagram of 8253. Here 24 pins, 12 on left side and 12 on right side. Out of these 12 pins, 8 are data bus, then 3, 3, these 3 and these 3. Means 9 pins are for counter. So 8 plus 9, and as shown in the block diagram, A0, A1 chip select, read, write. These are the control signals. Then power supply and ground. Only these pins are available in 8253. Data bus buffer. Data bus buffer means it is a logic buffer, means it is used for traveling of data. So we named it as D7 to D0. Control logic. Control logic means where we can have 5 signals: read, write, chip select and address lines A0 and A1. These 5 signals are used as control logic signals, and this control logic is responsible for controlling the whole operation. Here we can read and write using IO mode or memory mode, either IO mode or in memory mode. If it is in IO mode, then IO read and IO write signals are there, and if it is from memory, then memory read and memory write signals are there. Now, A0, A1 and chip select, these 3 signals are shown how a counter is selected. If all the 3 signals are 0, means counter 0 is selected. Respectively, 001 case, counter 1, 010 counter 2, and if it is 011, then it means a control register is there. Chip select is an active low signal, so it must be 0 in each and every case. If chip select is 1, then it will not be operating. Either A0 or A1 have any of the value, either 0 or 1, but if chip select will become 1, then this IC will not work, because chip select is an active low signal and active low signals will be working only on the logic 0. So control word register is accessed when lines A0 and A1 are at logic 1. As we see, A0 and A1, if both become 1, then only control word register can be accessed, and it is used to write command word which specifies the counter to be used, means which counter is used, which mode is there, either read operation or write operation. All these details will be given by control word register. This is 8253 timer control word. Now the format of control word is of 8-bit. We can say that the control word is of 8-bit. First bit, the LSB, is for showing the data, type of data, either binary or BCD. Okay. If it is 0, it means binary. If it is 1, it means BCD. M0, M1, M2, subsequent three values are for modes. Mode 0 to mode 5. There are 6 modes. All these 3 pins, D1, D2 and D3 pins, are used for modes. D4 and D5 is used for read and load function. RL0, RL1 means read or load. If it is 00, then counter latching operation. 01, that means read LSB. 10 means read MSB. 11 means read LSB first and then MSB, complete whole data to be read. And last two, SC0 and SC1, are used for selecting the counter. Either 00 for counter 0, 01 for counter 1, 10 for counter 2 and 11 for illegal. Means if both the pins are 11, this and this, then no counter will be selected. So we can say that it will be work only in 0, 0, 0, 1, 1, 0. So either or both of these pins, D6 and D7, must have a 0 logic. Modes of 8253. As we discussed that there are 6 modes, modes 0, 1, 2, 3, and 4 and 5. The name of the modes are interrupt on terminal count for mode 0. Mode 1 means programmable one shot. Mode 2 means rate generator. Mode 3 means square wave generator. Mode 4 means software triggered stop. And mode 5 means hardware triggered stop. Now see, mode 0, interrupt on terminal count. As the counter becomes 0, it will automatically generate an interrupt signal. If the 8253 is working in mode 0, it means once the counter is loaded with the number and it will become 0, then on occurrence of the 0, an interrupt will be generated automatically. Mode 1 means programmable one shot. Now we can program this device, and according to the program it will give one high and then it will go low. That means programmable one shot. Only one cycle will be high and then it will go low. Rate generator. Rate generator means we can provide on which rate we need the output, high or low. Means how much cycles we need high and how much cycles we need low. That means rate generator. It is used to generate a pulse equal to the clock period at a given interval. When count is loaded to the out stays high until the count reaches to 1. Means it will be depending on the counter. Once the counter is high and then the counter becomes low. Then mode 3 is square wave generator. The difference between rate generator and square wave generator is that the duration of high and low clock pulses will be different from mode 2. Means in mode 2 we can select up to how many period it will be high and how many period it should be low. But in case of square wave generator, it will be only for one clock cycle. Okay. Then mode 4, that means software triggered pulse. When 8253 is triggered using any command or instruction, then that mode is known as mode 4 and it will be known as software triggered mode. Software means instruction. When an instruction is triggering the 8253 or the interval timer, then it will be known as software triggered pulse. Last is the hardware triggered mode. It means when any other device triggers the 8253, then it will generate a pulse which will be known as hardware triggered pulse. That means mode 5. So 8253 can be triggered using any instruction or any other hardware device. I made this topic using the book written by Mr. Ramesh Gaonkar, which is specifically for 8085 processors. Thank you everyone.